Swayam Prabha. Digital India. Educated India.
Hello everyone, welcome to Groundwater Hydrology and Management, NPTEL course, week 11, lecture 2. In this week, we have been looking at data sources for understanding groundwater and properly managing it across India. We looked at the basic concepts and we have been looking at the most important data for groundwater management. And now we are almost at the end looking at groundwater quality. So what is groundwater quality so important in groundwater management? Let's first take a step back. Because while I was explaining the groundwater hydrology, the parameters, how it recharges, circulation, etc., seldom I use the word groundwater quality. This course is aimed at getting you through the groundwater management, assuming the groundwater quality is good. However, that is not always the case. Rainwater, if it is being collected and filtered and pushed into the groundwater, not much issues would be happening for the quality. However, while the rainwater is collected, and while it's recharging, there are pollutants also moving along with the water, which can go inside the groundwater and impact the quality. So it is important to understand why these quality issues are there and what are the data to manage it properly. For now, the physics, the chemistry will not be taught because we are almost at the end of the NPTEL course. I will talk about why groundwater quality is important. I will show you some slides on the data as per the government, and then we will jump into particular data across India. So, groundwater quality is also very important, as I mentioned. What do you do with quantity without quality? So this question I always ask students. If you have groundwater, and you assume, you say that groundwater is present, but if the quality is bad as in not consumable, not potable, cannot be used for industries, drinking, bathing, and or agriculture. One example would be a saline aquifer where the water is very salty. It cannot be used for most of anything. See, your aquifer is not like a bottle where water doesn't go inside, the other contaminants, etc. Other interactions also go, and that is why it is important to understand the geology, which we have done in the past lectures, and understand the groundwater quality. So what do you do with quantity without quality? For example, I have 10 a million cubic meters of groundwater aquifer, recharged and full, but if it is not good, you cannot use it. It's the same as surface water. You have a dam, but if the dam water is polluted, all the fish are dying. The lakes, if the lakes are polluted, the fish are dying, people don't use the water is black in color, those kind of things. So always remember that when we say improve the quantity, indirectly the quality is also should be good. The quality is not good and you're just recharging, then it's not of good use. This has happened in many cities across India when they started to do groundwater, rainwater harvesting and recharge activities. They forgot to make sure that the quality is not compromised. If the quality is compromised, it is not usable. Why? Studies show that groundwater qualities impact the human health, the industry, instruments, the livelihood options of livestock, and also the agricultural productivity if you use bad quality groundwater. Your standards are always set by CPCB, which is the Central Pollution Control Board. Okay, so which is getting references from the WHO standards, World Health Organization standards. So there are standards for water quality and specific standards for groundwater quality. There is a resource by the ISO, the Indian Standard Organization standards, where it gives you all these data, which tells you at what level it is acceptable to use the groundwater. Let's take, for example, table 1 in the book by CPCB. You would see that the color, Hazen units, max, everything has to be at an acceptable limit of 5. The order should be agreeable. The pH value should be 6.5 to 8.5, which is neutral almost. It should not be too acidic or too base. If it is like that, then you cannot have good water for drinking. Okay. So then the taste, turbidity, etc., all these are measures, physical measures. The turbidity, how much sediment is mixed in, the total dissolved solids, which is measured by milligram per liter. All these are done at a lab scale. So the physical parameters that we were looking at, the groundwater aquifer properties, the water level, rainfall, etc., are measured by an instrument in the field. However, groundwater quality, mostly you have to take the sample back to the lab, analyze it, and then give the results. Thereby, there is some lag time and a lot of cost involved, transportation, lab, etc. That is where you would see less water quality data than water quantity data. However, as I was mentioning, it is very important to understand the groundwater quality importance. Let's look some more of the ISO standards. Okay, so the standards are given here in 2012, given linked here. Okay, and the data is taken from CPCB, where you could see that multiple tables are there in this document. What we could see that is that these are the characteristics or the parameter they want to test. Let's take chloride, for example. Your chloride, milligram per liter, should be around 250 as an acceptable limit. If there is no other water resource, that's what this is saying. Chloride is actually sometimes they add it to clean the water in urban systems, the pipes, etc. But the pipes get clogged with chlorine or chloride. You smell chlorine water in the swimming pool, right? So all these are not acceptable after a level. So 250 is the best case here, as you see. If you go above 250, then what you should do is, for example, here, if you go above 250, you can go up to 1000. So 250 is normally the WHO standard, where all the countries in the world, developed, underdeveloped, everyone follow. Let's say European standards are 250. And then Indian standards, what they're saying is up to 1000, it is okay if you don't have any other water resource. Like that, they have given other relaxations. They're very strict on some parameters which are very, very harmful for human health, like ammonia here. Okay, no relaxation is given. Aluminum, they're okay. Barium, no relaxation is given. Boron, some relaxation, etc., etc. Let's look at fluoride. See, fluoride is something which is causing a lot of trouble in the groundwater because when you drink it, your bones get dissolved. Think about fluoride in your toothpaste. Why does it make your teeth look bright? Because it cleans part of the top surface out. Fluoride, chlorine, salt, sodium, etc. But fluoride is mostly used, right? So what does fluoride do is, it slowly takes a part of your top surface out. Like it's like acid you use for cleaning the rust. Some part of the acid also eats the metal. Okay, so you have to be very careful. When you drink fluoride enriched water, your bone density will deplete. and that is a big issue in Rajasthan, Gujarat belt, where geogenically it is mixed in water, which is the natural contaminant. The rock releases fluoride, and when people drink it, their bones get really low in density, and as a result, they get more fractures. They fall down. They cannot do heavy duty work as others can do. Okay, so these are still, they're giving some relaxations 1.5 as per the test, what test they should be using, etc. etc. So like this, there are multiple parameters. You should just check CPCB website and say water quality standards. You'll get all these water quality parameters, and they are very important to understand the quality of the groundwater. Okay. So one more table I'll look at is concerning toxic substances like cadmium, cyanide, lead. These are mixed in the water because of the industrial pollutants. Okay, pesticides is from your fertilizers. Okay, so there's no relaxation at all because these are potentially life threatening chemicals that are mixed in the water. So if you find this cyanide, cadmium, lead, you should not be given any relaxations to the groundwater. Just close it, don't use it. But however, as I said, not a lot of people know how much of these are present. So they eventually drink it and then go to the doctors if they have problem. Then they find out there's cyanide pollution in the water. And then this is the bacterial content. So now we are slowly coming from geogenic to industry. Now the bacterial. The bacterial mixes because of a leaky sewage system, open defecation, animals defecating in the wild. So all these have traces of chemicals and biological, bacterial contamination in the water. It is purely for drinking water, but then the water in the wells that you use for drinking should not have a trace. For example, if your groundwater well is right next to a sewer channel or your polluted waterways like along the Yamuna, then water can move into the groundwater while you pump it, and then you will be drinking it unknowingly. These you cannot see by eyes or by color. These are not physical parameters. So you need to test it. And that is where the data that I'm going to show next is going to be having a lot of understanding for groundwater quality. It is taken from the WRIS website. I will walk you through. Because of the number of data that goes in, it does take some time, but let's see how much it does when we open it. Okay, so I'll continue the lecture on understanding the water quality parameters. So how do I get here? I go to home. Okay, so from the home page, you go to the water data, and still we are in the groundwater. This is a groundwater course, so we are only focusing on the groundwater parameters, and the last parameter is groundwater quality. Okay, there are multiple agencies that collect data. One is your major contributor or major role player is the CPCB, Central Pollution Control Board. So they are the agencies that are responsible for collecting these data. They have the labs and they populate these databases on the WRIS system. So now you see all the number of monitoring stations across India in red. Okay, around 15,800 stations. However, the active ones are only around 14,600 stations that you see here. Similar to the other website data that we have looked at, you could actually go by state boundaries for basin boundaries. We will go at state boundaries to look at how data is collected. Let's say state, and then when you look at source. So here's where I said not many are allowed to even test it because some of these labs need sophisticated instruments which are only hosted by a government institute. So for example, CGWB, Central Groundwater Board, might have some locations, but eventually they will collect the sample and give it to CPCB because they have better labs, right? And then the other Telangana Groundwater Board, which also collects data. So let's look at all just for case, all agencies, and select a state. I'm going to go into Maharashtra. Why? Because it may have a lot of sample locations, and capturing all of this might take some time. So here we are. Maharashtra is now in yellow. So once this populates, then the total number, we populate the state, then the total number of your location stations also get adjusted. So here around we have 1,400 locations. So almost 10% are in Maharashtra, and around for same number you could say that is available in your active in the last 10 years. So they're very good in maintaining that in the last 10 years, how much data is coming. We can select a district. So we have been looking at Amaravati for the groundwater levels. So let's take Amaravati again. Okay, so these are the dots. The dot you see on the map are the number of wells. Okay, so or locations where they take a groundwater sample. It's a groundwater, not surface water, not the river water. So you don't see a river channel or something. It's a groundwater. They take a sample and they analyze the results. So before that, I'll just take one step back. So if you want to go one step back, you can just click here, India, Maharashtra. So you can see here district-wise count. So I'm just pulling down this table. You can see number of stations per district. So actually from here, you can say that Aurangabad has the most number of stations, okay, clubbed together. And then you could zoom into that monitored stations and total number of stations. Then you here see total number of stations that are monitoring these parameters. So pH is very important. As I said, it's a physical parameter. You can take an instrument and then put it and measure what the values are. Okay. So the other one you would want to see is your temperature, because too much temperature can lead to chemical reactions which can release more water, polluted water, etc. Then you have the electrical conductivity measure of TDS, sodium absorption, nitrate from your leaching, from your fertilizers and other things. So how these are coming, the physics, the chemistry, I will not teach, because again, as I said, you need at least a half a lecture, not a separate course for groundwater quality and chemistry. Here we're just going to say that groundwater quantity is important. We need to recharge. We need to use it sustainably, but also the quality has not to be compromised. And for that, we are going to look at these stations. So again, we're going to go to Amaravati. These numbers might be different when you zoom in more. Okay, so in 1,400 stations across Maharashtra, 84 are located in Amaravati. That's what it comes here. And then what you do is you have yearly or monthly. See, most of this data is collected yearly because they would assume that the water quality doesn't change every month. But let's click monthly just for case if you want to see. And then we're going to select date from when to when. Okay, you see there is a dash mark. The dash mark means there is no data in that period. So you cannot collect data. So let's go back to 2018, 17 Jan to 2022. There's no data for this year. So now we are in March, but there's no data collected. We can go to the last year, March. So there's almost a year lagging in the data. So I've clicked it, okay? And you could see that the same base map, gallery, etc. So if you have internet issues, as I said, you can put your street map. I'm going to use it just to quickly save the bandwidth for the class. And then you have the unit-wise selected here, okay? So now you can select each station either by clicking on the dot, if you know the location, or the station name. Let's say Amaravati Groundwater Estimation Committee well I want to do. And it zooms into that well. You could see that this is the AM Amaravati C. So I just clicked it and then this has come. So what it tells you is, it is a groundwater station It is a manual station, which means manually they take a sample out, not telemetry where you have an instrument which gives the data in regular intervals. Okay. And if you come down for that particular station, you could look at Amaravati GEC, what is the data? And here you won't have a graph or a trend line as other data that we see. You'll have all the parameters running from 2018 till here. Okay. So looks like 1 year they've been collecting data. And you can see calcium values are there, and then carbonate, fluoride. So for example, let's take fluoride, 1.46. What was the fluoride estimate that we had? Let me go back to that slide. We had around, the fluoride estimate we had was 1.5. So basically you're very close to that region. I will also go and show you the Gujarat website, just so that we can, or Gujarat state or a district in Rajasthan, so that we can look at 1.46. So again, this is kind of very close on the level. So if you click it, it's just a one data point you can see, and then you will find the data. Okay, so like this, you could download the data. I've already taught you how to download. Just click it. You will get the same model, or it will come as an CSV Excel file. You can download it. Okay. And then you could also look at other stations if you would like. Okay. So every entry you can go, or you can pick and choose based on the location. So Achalpur, I would like to click on that particular block, for example, and that station has populated, saying Achalpur would be populated now. You could see Tondagaon. The Tondagaon is the location. If you can see here, it is that location. The station name is Tondagaon. The location is in that same Achalpur near, and it is the Amaravati district. So within the district, that block I have selected. And you could see that the fluoride has changed, 0.164. In the previous data point, we had 1.46. Now it is 0.64. Like that, all these parameters can be checked. So the whole goal of today in this lecture is to show you how you could download this data. And I've given you water quality standards. Please look at the PDF of the slide. The link to the data is given. You could actually go there and read this bulletin and look at the standards, how these data look at. For example, if your village or your block has an elevated standard or an elevated level of water quality, you should be telling that there is no point of recharging the groundwater, because if the groundwater is very bad to start with, then you should not be putting more water inside, because it is not going to clean it. You should put it in a different location, because as you see, the wells between them have different water quality standards. Let's take this well. I've clicked this well. I don't know the name. It says Branatwada Tadi, same Amaravati region. You can see 0.54 fluoride. I'm just going to look at fluoride for now. Okay. Whereas in this location, Amaravati RH, okay, I've clicked it. Let's take some time. Okay, I'm going to click another one. Amaravati GEC. Okay, we have already seen it. It is 1.46. So where would I recharge more? I would recharge up north in the district, because those areas were having better water quality. For example, here I am in Hyderabad, and then if you see the fluoride, it's only 0.68 compared to 1.5. It is also lower than the standard given by WHO. So you could clearly see now where you could have these data. Okay. Normally there should be a submit button, and then all this data should come, but for some reason it is not showing all the data. It is only showing part of the data. As I promised, let's go back to Rajasthan. Okay, I've clicked Rajasthan, the state, and then all the wells in Rajasthan have come up. I don't know where, but let's pick one here. Okay, I'm just going to pick one well from the map itself. Okay, so I'm just going to click, and you can see it's spinning. Okay, so it does take. You can zoom in. Okay, so I'm gone to Bikaner. Bikaner is the district. And then I've clicked on a well. Okay, so you can click on a well. So now the district name has come up. Sometimes if you click on a well, there's no data. So don't worry about it. It will just be there as a location, but the data won't come. So now we are here. Okay, we have selected a well in Rajasthan, Bikaner district. Amarpura is the well station name. Sometimes the location is given as the station name. Okay, you could see all the parameters here from 2014. Per year it comes. Okay, and then when you download it, most of the data would be downloaded. Okay, your fluoride is 1.3, again, very close to the is above the WHO standard, very close to the ISO standard. So you need to be very careful in putting down this value. So it's very easy to find the standards. I'm going to show you how to do it, because what happens is as you search for these kind of data, sometimes the links do change. So it is very important for you to understand, also Googling what are the standards. Okay, so the WQ standards I'm going to share now. So all I did is CPCB, which is the Central Pollution Control Board. This is where you collect all the standards for all the water, be it groundwater, drinking water, surface water, also the bathing water, what water you should use. So you can come here, cpcb.nic.in, WQ standards. WQ is water quality. You can click on the water quality criteria, but this is what we need, the BIS standards or the Indian Standard Report. Part of it will be in Hindi, but you can also look at the, so for example, it starts with a different language. Since NPTEL is a course across the country, I would show the English version. Okay, so all these tables are here. Okay, all these tables are here. As I said, there's multiple tables that run into water quality. They would also discuss what and where can you give relaxations, why do you have to give relaxations, etc. And the references are given from where they took the methods and the standards. Okay, so again, going back to WQ standards, WHO standards are very important. I'm just clicking on it. It opens another tab. And these are the standards. Okay, so these standards are already taken. So for example, the fluoride, we found that it should be around 1.5. Okay, so 1 to 1.5 is the WHO standard updated in 2019. So somewhere that this report needs to be updated because it is 2012. In 2012, the WHO was saying 1, but in 2019, it says 1.5. So here's where you need to go back and forth between the WHO standard and the Indian standard. First, my recommendation is use the WHO standard for drinking water standards. If it does not meet the quality, then please look at ISO. If these two are breaching, for example, your aquifer groundwater is high in fluoride, there is no point putting in too much of water recharge structures. Because recharge structures, you put money and time and invest in capturing the runoff. So better to take the runoff and put it somewhere else, or not in the groundwater, you put it in a storage tank where you can use it, like on top of the surface. So not always your groundwater would be the best option. That's all I'm trying to say, because there is quality standards. With this, I would like to conclude today's lecture. For those who would like to understand more about the water quality, you can go here and look at water pollution, Environmental Protection Acts, etc. Since this course was on the management of groundwater, I just kept one lecture for the water quality. In my previous slides, I've also mentioned that almost everywhere in India, there is groundwater purification systems like your RO. Every house almost has a water purifier because your groundwater is slowly getting contaminated. Okay, it could be natural contamination like your iron, mercury, lead. Most of these are industrial, but your natural could be your fluoride, iron. You have iron here, etc. So there is sometimes you don't know which contaminant it is. So your industrial contaminants, your human E. coli, bacterial contaminants would be in a location where industrial or domestic population is there. But mostly other regions, you will have groundwater contaminated because of the geogenic contamination. For example, arsenic is very bad in the Ganges belt. It is one of very important parameter which is causing really bad health hazards in the Ganges belt. So we need to not use the groundwater. We cannot use the groundwater. There's no purification of arsenic at a low cost. So it's better to not use that groundwater or put more water into the arsenic leaden groundwater. Okay, so please think on these terms about water as a quantity is important, but you should also look at quality, and both quantity and quality go together. And you should put these recharge structures that we saw in the last class only in locations where there is no potential contaminants. With this, we have also closed the WRIS website's groundwater part. There is also other data that is needed to create the groundwater budget, because what we have here is purely the groundwater, data, all the data we have looked at. But there are other data that leads to the groundwater recharge, which is going to be taken from your water balance account, which we'll be doing in the next lectures. I will see you in the next lecture. Thank you.